Third case that we can take up is hexagonal closed packed structure. After discussion, that is very simple and very interesting drawing it has. That is, you can draw it the hexagonal. The name itself is first suggesting that you have to draw the hexagon. So let us try to draw the hexagon first. This is one hexagon. You can project the immediately second hexagon just below that. This is another hexagon. Okay, now the first thing that you have to do is put the atoms. Simplest way, put the atoms. Okay, this is done. Now what you can do is just cross connect the lines. This is very simple way, that's why I am telling just cross connect the lines. Okay, like this. After that, what you do is, you see here, this below line should be connected to this below line. So what we will do, we will project it like this. Okay, then these above lines, right, it will be projected to this above lines. So atoms of these above lines are projected towards downward to this thing. Okay, this is to be kept in mind. After that, you can connect the side atoms. Then you can connect the center atoms, right? This is your HCP. We can revise the structure. How we have done all the things. That is, the first thing, that is, you will draw the hexagon. Okay, just below that draw another hexagon. After that, put the atoms. After putting the atoms, just connect the lines by atoms. Look here, just connect it like this. Okay, then what you will do, the projection of these two atoms on these two above line. Above lines connected with above line, below line connected with below line, side lines connected with the side lines. That you have to take care. Atoms connections are different for all the things. Now look here, first is this line, so you can project it here just like this. Below is this line, so you can project it here. Okay, then is your side atoms, you can connect it here. Okay, then center atom, you can connect it here. This makes your HCP complete. Okay, now you can see the examples, that is, your cadmium, magnesium and zinc are basically having your HCP, that is hexagonal closed packed structure. Okay, this is the thing that one has to keep in mind. So we have discussed all the three cases. Then we will come up to one of the important parameter related to your catalysis and catalyst. Now what is the role, why this catalyst are important into the industry and what it does exactly, what are the criteria to choose the catalyst and what are the types, that we will be discussing today itself. Okay, now in that we can just see, just glance, you know that chemical reactions are going on, and it's not always necessary that all the reactions are always fast or all the reactions are always slow, right? And in industry, in order to get a good you can say good output of the products, so what we have to do, we have to use the certain substances which can increase the rate of the chemical reaction basically. So these substances are added. Okay, and they are added, why they are added, because we want something good outcome of the products, and that too within a very short time. Okay, time plays a very major role for the industries, and that's why the catalysts were invented. And I think the catalysts play a very major role in the chemical industries to accelerate or retard or the reactions and signifies their important. What are the criterias, what are the things, we will take a look on that. Okay, the first thing that is, will define the catalyst first. Okay, a catalyst, basically you can see here, it is a substance which can change the rate of chemical reaction without itself undergoing permanent chemical change. So what happens here is, a substance which can change the rate of chemical reaction without undergoing permanent chemical change, means it is just going to participate into the chemical reaction, but at the end of process it is going to get recover back into the condition it was earlier. Okay, so it is not going to itself change its properties. Chemical properties of the catalyst is not going to get altered at the end of chemical reaction. It will just play its role to accelerate or retard the chemical reaction. Remember one thing, that catalyst can never initiate, okay, or stop the reaction. It can always accelerate or retard the reaction. These lines are very important. You cannot expect, like you have a reactant A, you have reactant B, and if you say that I want product AB, and after that without adding catalyst or with adding catalyst the reaction is started, it's not like that. You are just helping the reaction to proceed, or you can say that you are trying to stop the reaction. Okay, that way the things are there. So in industry the catalysts play a very important role, and let us try to move ahead with the definition and its next topic. So as revised earlier, you all are aware, the catalyst is a substance which can change the rate of chemical reaction without itself undergoing permanent chemical change. Okay, so what happens, that the chemical properties of the catalyst are never going to get altered. It will involve in reaction, and it will just try to accelerate or you can say that retard the reaction rate, nothing else. So you cannot expect any catalyst to start the reaction or to stop the reaction. It is just like, you can say, the helping agent which is helping to accelerate or stop retard the reaction rate. Looking at the criteria, or you can say the characteristics of the catalyst. Okay, now when you try to understand the catalyst term, okay, it's very important that you should have idea about the catalytic characteristics, what a catalyst is and what are the criterias, what it should do, what it should not do in the chemical reaction, and that can be specified in terms of the characteristics of the catalyst. You can see here, the first is your specific nature. It means what? You cannot take a catalyst and say that I will use it for all the chemical reaction. It's not just feasible. Okay, a single catalyst cannot catalyze all the reactions, means the selection of catalyst differs with the types of the chemical reactions. Then you can see here, there is second point, that is unchangeability. Now what comes to the mind when there is unchangeability? Means a catalyst remains unchanged chemically at the end of the reaction. Means when the reaction is ending, okay, then your chemical properties of the catalyst are not going to change. So the first characteristics, that is specific nature, it means a single catalyst cannot catalyze all the reactions. The second thing is that unchangeability, means what? A catalyst itself remains unchanged chemically at the end of the reaction. The third thing that you can see here is catalyst does not affect the position of equilibrium in reversible reaction. Like you have a reactant A and reactant B forming some product AB, and what happens in reversible reaction? Your products can get back converted to your reactants. But the good thing is that catalyst is not going to affect the equilibrium of this reaction. Okay, so that is very nice thing about the catalyst, that equilibrium is unaffected in the case of reversible reactions. You can see here the next thing, that is efficiency. Okay, Efficiency means what? How powerfully that particular catalyst can accelerate or retard the reaction defines the efficiency of the catalyst. Okay, so you can say here very clearly basically that you have, if I give you a lump form and if I give you a powder form, then which one is more effective? You all are knowing that what happens in case of if I have a chalk and if I give you a chalk dust, what happens for that case? You know that chalk dust is having more surface area, right? And when there is more surface area means more catalytic sites are provided and hence the reaction rate will be faster. So what happens? The lump form of catalyst is very less preferred, and due to this the powder form of the catalyst are preferred in most of the cases. The reason is that the powdered form of the catalyst has a more surface area, and due to this more catalytic sites are available and hence more reactant molecules can come and sit on that, and hence the reaction rate can be increased effectively. Okay, and that defines the efficiency of the catalyst. Now we can see another criteria, or you can see the characteristics, that is a very small amount of catalyst is enough to accelerate the reaction. What does that mean? See, like it's not always necessary that if you are taking a very large amount of chemicals and you have to add a very large amount of catalyst to accelerate the reaction. A very small amount sometimes is very sufficient to just accelerate the reaction. So that is again a positive point of the catalyst, that it saves a lot of chemicals and definitely it will be saves lot of the waste product, and recovery of the catalyst at the end of process becomes much easier due to this point. Okay, the sixth point that we can see here, the catalyst cannot initiate or stop chemical reaction, it only accelerates or retards chemical reaction. A very important point that one has to remember in the mind while discussing, that is a catalyst, if you are trying some reaction, okay, a catalyst will not start that reaction. Okay, it will just participate into the reaction that is already going on, which is already in the process. Okay, so like you have a reactant A, you have reactant B, you will try to react it something like this, A is there, B is there, and if you try to react it, product AB is formed. Okay, so this process is going on. Okay, it's not like that you are adding catalyst and catalyst is then starting the reaction and then your product is formed. No, your catalyst is simply, it will either fasten the rate of this AB reaction or it will simply slow down the rate of this AB product reactant reactions. That one has to remember. So if it accelerates the rate, then what happens? Product AB will be formed very fast. Okay, within very short time you will be able to get a large products, that is very preferable for the industries. But if you see that your catalyst is working in the retarding facility, then what happens? It will retard the things and your product AB formation will basically get slowed down. Okay, that is the thing one has to remember. We'll try to summarize the points in the short, that is what are the characteristics of the catalyst. That is the very important first point we have discussed, is the specific nature, means a single catalyst cannot catalyze all the reactions. The second thing that you can see is unchangeability, means your catalyst remains unchanged chemically at the end of the reaction. The third thing that you can see here is catalyst does not affect the equilibrium position in case of reversible reaction. Okay, so equilibrium is undisturbed in this case. You can see the fourth point, that your powder form of the catalyst is more effective than the lump form. Okay, why it is so? Because your powder form will have more surface area and due to that more catalytic sites are available, hence the reaction rate will be faster. The fifth point, the small amount of catalyst is enough to accelerate the reaction. Okay, you don't have to add a very large amount every time to just accelerate the reaction. So that saves the chemical and recovery of the catalyst becomes easier when you are using very small amount. The sixth point that is very important to be kept in mind while choosing any chemical reaction and catalyst, that is the catalyst cannot initiate or stop the chemical reaction, but it only accelerates or retard the chemical reaction, and depending on that your product formation will be either faster or slower. Okay, that's enough for today. We will continue in the next session. Thank you so much.